guys are too easy. Okay, so that's just it's a straightforward formula, a straightforward calculation, but you got to remember how to calculate these things if you have a homework problem with rotation. Let's look at sort of a hypothetical problem we could do that would be kind of fun. Let's imagine the kinetic energy of a rolling disk. Kinetic energy of a rolling disk. Okay? So we thought about rolling a little bit when we did rotational energy. You have a disk with mass m, radius r, and remember its center of mass went forward at v, but at the same time it went around at omega. That was kind of the idea, right? It's not bad. Okay. So let's think. Let's compare. What's higher? Is it k translational or k rotational? Classic potential multiple choice on an exam, maybe. Okay, well, we just calculate them with the quantities we're given. There's no numbers, but you can use symbols. So k translational, well, we have that one. It's just 1/2 mv squared. We have m, we have v. There's nothing to do. mv squared. And then k rotational is 1/2 I omega squared. So you say, well, I don't know, because you didn't give me any numbers. Which one is higher? We don't know I. We don't know omega. Well, we could get I, though, because it's a disk, and it's mass m raised r. Okay, we can get I. 1/2, don't mix that up with the 1/2 in here for a disk. M r squared, omega squared. Okay, so now we have it both in terms of m, and r doesn't matter for one, does for the other. So you still don't know which one's bigger, do you? No. How are we going to figure out which one's bigger? See, this would be the part where can you see it? You get the connection. Think back to the first part of the class, there's a connection between the two. Remember, and the problem would have given you hints and been real specific. It's rolling without slipping. Rolling without slipping. Without slipping means that the translational velocity is the same as the velocity of the edge of the disk. Right? The translation of the whole thing is the same as the tangential velocity of the edge. Or that formula you may recall, V equals omega r. Remember doing that? Oh, God, I didn't have this thing on. When will the PHYS problem be uploaded? Very soon, later today. Yep. Do you have to square that omega? Yeah. Oh, did I leave it off? Squared. Oh, yeah, that's right. Now you'll shout out the number now that you've confirmed. Okay, so now if we basically realize this, then we can say, oh, okay, now we can actually get everything in terms of m and v. 1/2 mr squared. Omega is v over r. Squared. Okay, so now you see what's going to happen is the r squareds go away. This is squared there. So you get 1/4 mv squared. Right, so rotational is 1/4 mv squared. So the answer is translational is the winner. Okay, translational is bigger. Thought they engineered it enough, but they didn't know what they were doing. Let's see. So now, am I telling you that for everything you ever do in life, that translational kinetic energy will be twice rotational? No. Okay. So you could have this object. Let's imagine this thing just floating through space, no gravity or anything, and say it's spinning like this really fast, right? And it's barely rotating. Then its rotational is probably bigger than its translational, because there's a lot of energy in the rotation and very little in the translation. Okay? Or you can imagine it's translating really fast, and it's slowly rotating like this. Oh, now its translational is bigger than its rotation. The only thing that let us be specific in this case is because we were rolling without slipping. There was a relationship between the two. But I'm not trying to tell you that these are like inherently coupled to each other. They can be any value they want. It's just rolling is a special case where the one is always a certain fraction of the other. And it's not even always a factor of 2. Right? That was because this is a solid disk. What if it were a sphere? Ooh, then that would be 2/5. What would that do? I can't do it in my head. That's just an example, like a quickie little symbolic problem. Got it. We could ask you that for a sphere. Let's say that'll be on the exam. I don't know. Okay. So that is the most I could possibly talk about work. Okay, for what we're doing so far. Now, I'm sorry, that was the most I could talk about kinetic energy for what we've done so far. Now let me look at work.